Okay, here we go. Good times. So it says again, graph this original function. And yes, Danika's got it this time. It's a parabola because it has a degree of 2. I feel like that's really bright. Okay, so we know that it's going to be a parabola because it has a degree of 2. That means the highest exponent is 2. This is, it's not, but it kind of is. Okay, it's in technically standard form, but it's got no b, so it could be either. Okay, so this is like both and neither all at the same time. Okay, the graph of the function is this, and graph this function and its reciprocal. So you're doing 2 graphs on 1 coordinate plane again. Okay, so let's just deal with this one first. Let's graph this parabola. So I need the vertex, and I need the x-intercepts. Okay, you guys can do the x-intercepts right away. Factor this one. What do you know that is? Difference of squares. So it's going to be x plus 2, x minus 2. So my x-intercepts will be at -2 and +2. Right? Like, do the things that are easiest for you right away. Right? X-intercepts, we can factor that. Okay, what's the next thing I need when I'm graphing a parabola? I need my vertex. So I'm not going to complete the square on this one. I'm actually going to do my secret formula because I don't have a b value. And so I think completing the square would kind of mess me up, or not. I might not know what to do without that b value. So I'm going to do my secret formula. So x is equal to -b over 2a. What's my b value? It's 0, because there is no b value. Remember that your equation goes ax squared plus bx plus c. You have no x term. So if it's no x term, it's 0. And that would be 2 times 1. I guess it really doesn't matter, because that would be 0 over 2, which is 0. So that's the x coordinate on my vertex. Yeah. Okay, so x coordinate of vertex, we're going to substitute that back into the original. So y is equal to 0 squared minus 4. So y is equal to a -4. So my vertex is going to be 0 and -4. Now I knew this just looking at that. Like, I didn't have to do any math to do it. Again, I've got lots of experience, guys. Like, I'm not saying it to make, well, I'm kind of showing off, but I'm not saying it to make you feel bad or that you're not getting it, but some people might see it. So this is like saying y equals x plus 0 squared minus 4. That's vertex form. What's my vertex? 0, -4. Right? So like, you can do it either way is what I'm trying to show you. So that if you're not confident to do it this way, and the only way that I know this is because I've done it lots of times. There's no b value. So like I said, it's kind of standard form, kind of vertex form, but it just doesn't show you the +0. So I knew by just looking at it, my vertex was this, but by doing the math, it also showed me that. Like, there's no shame in doing the math to confirm that what you think is right is right. Like, that's what we call checks, right? I would much rather double check, find a mistake, than do a whole question, walk away, and get 0 marks because it's wrong. Okay, so let's graph that. Let's graph that. How are we gonna do our increments here? You want to do them by ones? Well, this is a nice graph. 5, -5. You guys cool if I just do it like that? Or do you want me to write them all out? Doesn't matter, you guys are flexible, I like your flexibility. So I'm gonna plot the information that I have. So my vertex, 0 and -4, are 2 and -2. And now I'm gonna connect the dots with a smooth curve. We can't have it pointy, because that's an absolute graph. So you're gonna connect them with a smooth curve. Gonna put arrows on it, and I'm gonna label it f of x. What else do I need for this graph? Nope. 2 points labeled, right? So let's do that right now so we don't forget. So I'm gonna label my vertex, and I'm gonna label this point. If you wanna label all 3, have at her. Okay? Now we're gonna do the other one. So I would suggest that if you get on the test or the quiz and you have no hot sweet clue how to do this, at least graph the original function. You'll get, like if this was a 5-mark question, if you graph the original function, you're probably gonna get a 2 out of 5 on that. Okay? Because you didn't do the hard stuff. All right, so now here we go. Okay, PowerPoint's opening for some strange and odd reason. That's alarming, everybody. Okay, my computer's possessed. Okay, so what we're gonna graph now is the reciprocal function. Oh, I circled that and you guys can't see it. Reciprocal function. So that is f -1 of x is equal to 1 over x squared minus 4. I like to take the time and write that out just so I remember that the reciprocal graph has that 1 on top. Okay, so we're going to do our asymptotes first. So we're going to do our vertical asymptotes. Yes. Okay, so my vertical asymptotes are my NPVs. What are my NPVs? 0. Nope. Positive 2, negative 2, right? Because remember, go back to chapter 6. You just finished it, right? So, and didn't we just do this? Does this look familiar to everybody? Didn't we just do this, like right here?
Well, that's completely different.
Completely different. It's completely different. What were they in the original function? Right? And what did they represent on this graph? X-intercepts. Right? You guys are going to start making connections. I'm going to connect the dots for you guys right now. The x-intercepts on the original graph turn out to be your asymptotes on the reciprocal graph. Why? Because what's your y value here? What's your y value here? 0. So if you reciprocate 0, what happens? It's an impossible number, so it becomes your asymptote, right? So the reason why these become my asymptotes is because the y value here is 0. And if I reciprocate 0, the denominator 0, and that's bad, oh bad. Okay, so I'm going to put on my asymptote. And what do asymptotes have to be? Straight dashed lines, because they don't exist on your graph. They're invisible boundaries. Yeah. Because how many non-permissible values do I have? 2. So I've got 2 asymptotes. Your asymptotes are infinite up and infinite down.
Yeah, but
so
if it's like something like x to the 3, would it be 3 asymptotes then?
yeah, you'd have 3 then. Yeah, we never get to that though in a pre-calculus course, whether it's 12 or 11, we never ever get to that. We only deal with squareds, okay? We have enough time, we have a hard enough time with that. Okay, let's now talk about our horizontal asymptote. This is a always for grade 11. I'm assuming you mean y equals 0. Yes, okay. That's an always. Always for grade 11. That's what I'm going to put, because it's not always. I don't want you to come to my grade 12 class and say, you said last year that it was always here. Because we're going to move them in grade 12. But we're starting out with baby steps. We're starting out with training wheels. So I put my asymptotes on there. So remember that asymptotes have to be a dashed line. If you put it as a solid line, you're going to lose marks. Okay, so anything that's an asymptote has to have a dashed line. You know what we haven't talked about? Invariant points at all. And we need to go back and look at those.
Those are,
Invariant points are the point that stays the same between the original graph
we talked about this.
and the reciprocal graphs, but we haven't done it at all in here,
In this.
in this.
Was this on the last one?
Did we?
Yeah, the last.
Look at me. I think we did it on the very first one.
Yeah.
Okay.
We only did one.
Okay, alright, I'm doing my best. I'm trying to do my best. Okay, so now let's find our y-intercept. So I did my vertical asymptotes, I did my horizontal asymptote. 3, I'm going to do my y-intercept. So that's going to be,
One over negative 4.
right. So y-intercepts are when x is equal to 0. So 1 over 0 squared minus 4. So that's going to be 1 over negative 4. What?
Okay, yeah,
And really, could I have found it without doing the math? Yes, because what would we do here? We'd look where our parabola crosses, and we would reciprocate that. What's the reciprocal of negative 4? 1 over negative 4. It's right there. That's exciting. All right. Step 4. Step 4. I'm going to do a table of values. Okay, so let's look at the sections of our graph because that's going to determine our table of values. I keep moving up and down. This is annoying. Okay, so when I look at this, I need to figure out what the points are doing to the left of this asymptote. I need to figure out what the points are doing between the two asymptotes. And I need to figure out what the graph is doing to the right of this asymptote. Does that make sense? You got 3 sections. So you need x values. You need to figure out x values. Would you guys agree that this is section 1, section 2, section 3 if we were to break this graph down? 1, 2, like to the left of the asymptote, in between the asymptotes, to the right of the asymptote. So when we do the table of values, we need to have some values in section 1, need to have some values in section 2, and we need to have some values in section 3, right? So my asymptotes are dictating what values I'm going to pick for my x. I'm not going to pick negative 2 to positive 2, because that would only give me this. So I got to pick some out here, I got to pick some in between, and I got to pick some to the right. Okay, table of values. Do you want to do 3 table of values? We don't do a lot of points in them, but do you want to keep your table of values separate into the sections or just do it all at once? Okay, I don't have a ton of room. I was hoping you'd pick the 3 choice, but it's okay, I'll get over it. Okay, so let's start left of this asymptote here. So this is my negative 2, so left values. Pick some values that are left of negative 2. Negative 2 isn't an option.
Negative 4, negative
-4, -3. I like it. Why am I not picking -2?
Because it's
Cause
like,
It's already an asymptote, right? Like, so I'm not gonna pick -2 then. I know I'm gonna get an undefined at that point, cause that's my asymptote. Okay, so let's pick some values in between. So Danica, you said 0, but I already got 0. -1 and 1. Okay. Yeah, I'm gonna have to make another because I just ran off my page. Do you guys know why I'm putting squiggly lines in there? Because that's to the left, that's in between, and now my right. I ran out of room in my table, that's why I'm moving over here. So 3 and 4, I like it. We don't need a lot of values, we just need it to kind of guide us where we are. Are we above the x-axis, are we below the x-axis? That's all we need it to do. Okay, deep breath everybody. And we're gonna do some mental math. So we're gonna substitute -4 into here. So -4 squared is 16. 16 minus 4 is 12, so this is gonna be positive 1/12. So 1/5, but it's a positive, right? Okay. Nope, both are negative. Do the math. Yes, you are.
Oh, I see. It's just gonna be a straight, it's just a straight line.
Pardon? For 3? Or for this one? It's a negative for sure. Oh, 3. Okay. 3 squared is 9. 9 minus 4 is positive 1/5. And positive 1/12. Okay, so remember when I said your assignment, the graphs weren't big enough, you guys really need to do them on graph paper? This is why. So you're gonna get close, but you're not gonna be exact. I'm looking for the shape of the graph. Okay, here we go, we're gonna graph. Okay, everybody take a deep breath, we're gonna graph. It's okay, guys, it's okay, it's no big deal. What is a smaller number though? Is 1/12 smaller or is 1/5 smaller? 1/12 is smaller. So just know that 1/12 is closer to the asymptote than 1/5 is. I'm not gonna get picky, there's gonna be no rulers. Megan, are you okay? You're like staring off into space, like I've lost you. You're good? You got this? Okay. So at -4, so that's that point right there, at -4, I'm at a positive 1/12. So I'm really, really close to that line. At -3, I'm at a 5th. Okay, just everybody breathe. Everybody breathe. This point is 1/4. This point here is a quarter. So is 1/3. It's a bigger number, but it's negative, so that means it's going to be down lower. So it's going to be about here. And it's got a matching spot on that side. Those are not level. Imagine those are matching. What don't you get? We're plotting points. Oh, but it will? But now okay. I know what Danica's, she's having an emotional trouble. Dismos. When all else fails, go to oh. Not where I was supposed to go. Okay. Where is, how do I spell it? Thanks. Oh, I take it to Sketchworks. I'm sorry, guys. It happens. You spell one thing wrong and you're on the dark web looking at things you should never look at.
That's not how it works.
What?
Misspelled L1 on the dark web.
Okay, so I think what Danica was saying is that we've got these two beautiful smooth curves. Where are they? Because that doesn't make sense with this one. But what's the difference between the graph we're graphing? We're doing a parabola. So this one only had two sections. So you're gonna see your smooth curves really soon. But now we have a third section.
Yeah, show us how I see the work.
No, I don't wanna ruin the fun. Okay. Yeah, we'll do it after so we know what our graph should have looked like. At 3, we're back to positive, so positive 1/5. And at 4, we're at a 12th. Okay, so now we're gonna connect things with smooth curves that approach the asymptotes but never touch them.
Yes.
What? Yeah. That makes sense right there.
This is like taking a lot of concentration.
How picky you gonna be about this like asymptote getting close to the line without touching?
Pretty picky.
I'm gonna fail.
No, you'll just lose half marks.
Half marks, that's the 40 lesson.
Half marks.
Okay, so do you see those nice smooth curves now? There. So this side and this side. But this almost looks like a parabola, but it's a little bit flat along the top. And remember that this graph is our f negative 1. So we need all 3 parts of this graph to make it beautiful, to make it perfect. Okay, so what do we need still for this graph? We've labeled it, and now we gotta label 2 points. So I'm gonna pick a point here, which is -4 and positive 1/12. Guys, we figured that out. That was in our table, right? Like that was. And then I'm gonna be wild and daring. And label something totally on the opposite side. That is the exact same.
That says
Then
one
you're
half.
good.
That says one half.
And then I'm done. Oh, sorry.
Wild and daring and get it wrong.
Wild and daring and I get it wrong. This is what happens.
What does it say?
That says 1/12. I don't know why you can't read that. It's perfect. Invariant points? Okay, we're gonna talk about those. Invariant points are good to know and where they happen, but this one would be really hard to figure out. Okay, I got a question for you guys. What is the only number that you can reciprocate that will be the same? 1. So does your x have to be 1 or does your y have to be 1?
X.
What was okay, in our table of values, what were the things that we were reciprocating? We were reciprocating our y's. So when your y is 1, that will be your invariant point, whatever x is. So your invariant points happen when y is 1. Okay, so that's what our graph should have looked like, and it kind of does, guys. Like we did good. What do you see labeled here?
Points.
Points. What are these ones? So invariant points are super important, and graphs will pick so this is like a math graphing software, right? So it does these things. That's an invariant point, and you know that they're shared because guess what? The point's on the blue line, and it's on the red line. But as you can see, that's not a very nice x value to go with it, right? This side, my y value is 1. So what we can say, I'm looking at my screen and it's not moving. Okay. Yep. Because 1, the y value of 1, when it's the only number when you do the reciprocal of it, it is the exact same number. Okay, so we're gonna do a star and a little note here. Oh geez, I'm moving stuff around.
Fine.
I don't know what the thing is. Okay, so to find invariant point, because when y is 1, if we reciprocate 1, 1 is still 1. So let's actually solve them. We know where they are for this graph. I'll give you a second all to write that down before I give you more math to do.
What are we doing?
We're going to solve for our invariant points.
Whoa,
Okay.
I got one side perfect. Mine's like exactly at one.
Okay, we good? Okay. So what are we going to do? We're going to take our reciprocal graph. Okay. Does it matter if I use my reciprocal graph or my original graph?
No,
Why?
because one equals one and
What's the definition of an invariant point?
It's the same on either one.
It's the same on both graphs. So does it matter which one I'm going to solve for? Let's do the easy one. Okay? Let's work smarter, not harder. So you can use either, but because an invariant point is the exact same point on both graphs, let's use the easy one. So y equals x squared minus 1. We're going to, no, 4. It's 4, everybody. We're going to substitute 1 in here. So we've got 1 equals x squared minus 4. What am I going to do? Move it over. We're going to add 4 to both sides.
5
Oh.
equals x squared.
Oh, geez. You said 5, I wrote 5. X squared equals 5. How do I get x? Square rooted, everybody? Is that what you meant? It is ugly.
What if
So,
what if it's a 2 in there?
yeah, so?
That's
So you're going to do the square root of 5. So on my calculator, it comes out to be 2.24, and rounded, of course. Is that the only answer? No.
Negative plus
I need plus minus, right? So we know we're going to have one coordinate at negative 2.24 and 1, because we substituted 1 in here. And we're going to have another point at positive 2.24 and 1. And let's check our graph. And if I hover over these points,
It's you rounded.
I rounded, they rounded to
rounded.
3 places.
Yes, but you rounded up and you should have rounded down.
No, I shouldn't have. I went to, 2.24 and yeah, I did it right. I did.
With Bunny's computer.
I did it
Okay,
right.
okay, yes,
Jacob. Okay, I do make mistakes on a regular basis, so it's okay to ask. So does that make sense? Everybody knows how to find the invariant points if I ask, even if they're ugly? You can solve it mathematically, which is way nicer.
Is it still minus 1 too? Like, is there invariant points?
Nope. Yes, negative 1 would be the same as well. Oh, I totally forgot about those ones.
No, can I read the bathroom?
So there's
Sure.
four.
Don't, just go, just go.
Let's go.
Don't walk around the hallway. 'Cause-
In here anymore? Are we learning anything else?
what did I miss? I missed 1.
Because there's negative 1.
There's negative 1 and positive 1. Oh,
Let's go.
so let's go, let's do it.
Won't matter.
Can we do it on our own?
Yeah, you guys do it on your own.
So to find
Okay.
the invariant point,
Negative
y
one.
has to equal plus minus 1.
Okay, so you guys do it on your own. I am gonna do it on my own. Oh my goodness.
I got it.
Did you?
Yeah.
So I got invariant points, well I didn't, Desmos did, at negative 1.732. And if I slide over to the other side, it should be a positive. And remember what I said about symmetry in these graphs, right? Like these rational graphs will have that same kind of symmetry. So if you get one that is wonky, then chances are something's wrong with your math. And it makes sense though that you would get the same. I'm pointing at my page and you guys can't see it. It makes sense because when you do the square root of 3, all you're doing is adding the plus minus. So those should be the exact same number.
I got it.
Okay? So that's how we find our invariant points. 30 minutes to do one question. That seems intense. Okay,
Yeah, we have to do
you guys have 8 graphs to do.